We're just talking about antiderivatives and how to find antiderivatives. And now we're looking at a problem. These are usually called initial value problems. And the following example says that find an equation of a curve whose tangent line has a slope f prime of x equals x to the 2/3, given the point 1 3/5 is on that curve. So we are given the derivative, and we can find the original function f of x by taking the antiderivative of the derivative function. So let's look at the integral of x raised to the 2/3 power dx. So take the antiderivative, we add 1 to the exponent. So 2/3 plus a 3/3 is 5/3. We divide by our new exponent. So technically, if you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So instead of just writing it as x to the 5/3 over 5/3, we can just say this is the same thing as x to the 5/3 times that reciprocal, which is 3/5. And that just makes it a little easier. And then don't forget that we have to add this plus c. So we have f of x is equal to this 3/5 x to the 5/3 plus c. We can figure out what c is because we're given that there's this point 1 3/5 on the curve. So we know that when x equals 1, f of 1, our y value we get back is 3/5. So we're going to use that fact so that we can find c. So let's go into this function. We're going to let f of x equals our y value when x is 1. So 3/5 is equal to this 3/5 times x, but x is 1 here. All raised to the 5/3 plus c. Okay, so let's solve for c. Well, first thing is exponents, 5/3, 1 raised to the 5/3. Well, 1 raised to any power is 1. And so we have 3/5 equals 3/5 plus c. And so if we subtract 3/5 on both sides, we get that c is equal to 0. So we found the equation of the curve. The curve would be f of x is equal to 3/5 x to the 5/3. C is 0, so adding 0, I don't need to write that. So this next example, the direction says, given the marginal cost function, we want to find the cost function. And we're given that c prime of x, which is the marginal cost, is equal to x plus 1 over x squared. And we're given that 2 units cost $5.50. So since we're given the derivative, we can find the cost by taking the antiderivative or the integral. So we're going to look at the integral of x plus, instead of writing it as 1 over x squared, let's rewrite it as x to the negative 2 power. And then dx. So now it's in the form, we can take the antiderivative. So add 1 to our exponent and divide by our new exponent. So the antiderivative of x is going to be x squared over 2 plus the antiderivative of x to the negative 2 power, add 1 to our exponent, we get -1. Divide by our new exponent, -1, plus some constant c. Let's actually call it k, because our function is in terms of c, so we don't get confused. So right now, we found that our cost function is equal to x squared over 2 minus 1 over x plus k. We need to figure out what k is, and we're going to use the information that we're given to find that. So at 2 units, this is telling me that c of 2 is equal to 550. So let's go in here for c of x. Let's plug in 550 is equal to, and let's plug in 2 for our x and solve for k. So we get 550 equals 2 over 2. Nope, it's 2 squared over 2 minus 1 over 2 plus k. So 550 is equal to 2 squared is 4. 4 divided by 2 is 2 minus 1/2. Well, 550 equals, well, half is 0.5. So let's think of this. 2 minus 0.5 is 1.5, or we can say 1.50. And I'm just doing that because this piece is in decimal. We might as well write 1/2 as a decimal. And then we have plus our k. We want to solve for k, so let's subtract 150 on both sides. So we have 550 minus 150 is 4, is equal to k. So we found what k is, and we want to go back into our cost function, and we want to plug in our k value. So we found our cost function, which is x squared over 2 minus 1 over x plus 4.